All right, this is our last section, the last new material that you will learn. I'll pause a minute for you to get a tissue. I'm sure you're very upset. The rectangular coordinate system is what we've always graphed on. There's something called polar coordinates. Maybe you've noticed it on your graphing calculator. We're first going to learn how to plot points in the polar system, but I do want to show you. If you go to mode, right here beside the yellow, we're used to going back and forth between radian degrees. Up here, maybe you've done a little bit with the normal is what we're usually in, but we can be in scientific notation if we'd like. Down here, we're always in function mode, right? We're graphing functions, y equals blah, blah, blah. There's parametric mode and there's polar mode. And we're going to be doing a little bit of that today. Okay, so let's think about what we mean when we say x and y. Points are identified by their distances from the x and y axis. Go ahead and put that on your notes. Distances from the x and y axis. In the polar coordinate system, we still have points, but they're identified by their angle on the unit circle and their distance from their origin. Okay? So let's look down here. Okay? You can use your notes there to fill in, or I think I have a blank axis for you. Usually in the rectangular coordinate system, we call this 0, 0 spot the origin. In polar coordinates, they refer to that as the pole. Okay, if they say go back to the pole, they mean the origin, the point 0, 0. Okay? And we have the x-axis, or our positive axis, and we have the y-axis. The x-axis is referred to as the polar axis. Okay, the positive x-axis we refer to as the polar axis. Okay, and I'm not sure what the y-axis is called. It's just, we have the polar axis and the pole, and then we have this radius. Okay, I can call, in the rectangular system, we call this xy. That means from 0, 0, I went x in the horizontal direction, y in the vertical direction, and then put a dot. Okay, in a polar coordinate, it's the same point. Okay, I'm still going to talk about, notice it says the polar coordinates represent the same point, but it's described by the distance from the origin, which is r. This is how far is this? Okay, if I was going to measure this, how far would that be? And its angle from the positive x-axis on the unit circle. Okay? Theta. So instead of xy, it'll say r theta, but when I plot it, it'll be at the same point. Okay, and to translate back and forth, we use the trig that we're already familiar with. We know this trig. Okay, r is sometimes called the radial coordinate, and theta is called the angular coordinate. I doubt we're going to use that vocabulary a lot. Okay, but I felt like I needed to put it there. I'm actually using notes, guys, that I used when I taught Calculus BC, AP Calculus BC. We do polar coordinates then as well. Okay, so just for you to know. All right, so to go back and forth, it's no different than, we're not learning anything new here, gang. Sine of theta. Let's go back to geometry. Opposite over hypotenuse. Trig class, we called it y over r then as well. Cosine, adjacent over hypotenuse, x over r. Tangent, opposite over adjacent, y over x. Well, now what that means is, therefore, x is going to equal, I have this in your notes a little differently, but x equals, okay, if I would multiply both sides by r, x equals r times the cosine of theta. Y, let's see, I multiply both sides by r. Y equals r times the sine of theta. From the Pythagorean theorem, I think we know how to find r if we know x and y, right? Okay, so what we have is r squared equals x squared plus y squared. We did this before. R is the square root of x squared plus y squared. So if I have rectangular coordinates, I can find the polar coordinates. I can find the r theta. Okay. Now, every xy coordinate just defines one point on the rectangular coordinate system. However, polar coordinates are not unique. Think about it. We can go round and round and round with our angles. We might have the same r, but we'll go round and round and round. And positive and negative directions, all that stuff. Okay? So, in general, if a point P has coordinates r theta, then we could say r theta plus 2 pi n, or r theta minus 2 pi n. Every point has infinitely many pairs of polar coordinates. Okay? Usually we're going to give the smallest positive angle. Okay, that's usually what we'll do. We won't call it 790 degrees. You know, we'll pare that down to the smallest positive coterminal angle. So let's try it. Let's convert 3, 4 to polar coordinates. And I'd like you to give me 3 different, I don't mean 3 different ways really, 3 different polar coordinates that correspond to 3, 4. Here's 3, 4. There's only one 3, 4. Just one. Okay? I would like to also be able to plot 3, 4, but I would like to call it r theta. All right? So, in other words, I need to know this distance r. I need to know this angle theta. That's what I'm asking. So that I would still plot it at the same spot. Well, we'll just draw our little triangle. I know that this side is 4, this side is 3. Okay? So it's pretty easy for me to find r. R squared equals 9 plus 16. R squared equals 25. So r is 5. Great. So far I have 5, comma, I don't know. I need to find this angle theta. I do know that the tangent of theta is 4/3. So I know theta is the inverse tangent of 4/3. So I will just go right ahead and do that on my calculator. Let's work in degrees right now. I don't think this is going to be pretty. So inverse tangent of 4/3 is about 53 degrees. Okay, so I am going to round to the nearest tenth and say that it is 53.13 degrees. That's pretty, I feel like that's pretty accurate. Okay, so one of my answers is 5, 53.13 degrees. Okay, another way might be to describe it. I'll just add 360 to that, right? Let's add 360 to that. Plus 360. There we go. I'm going to say it's 413.13 degrees. Okay. And then I might just take, maybe I want to go this way. Okay, so I am going to take 360 minus 53.13. Right? Wouldn't that give me how many degrees this is in the negative direction? Okay, well, I should have taken 50, sorry. 50, I want to get the negative angle. 53.13 minus 360. And we'll get negative 307.87 degrees. There's another way to describe it. I'll still have, they're saying go to that angle and then draw a distance of 5. So all three of those give me that. I could put it in radians if I want. I do want to show you a way that we use negative, okay? This gets a little, I'm not going to use this a lot, but I do want you to see it, okay? If I would choose to use this angle, okay, right here, which I don't know why I would. Most of the time we do this when we're down here. But anyway, an angle that's exactly 180 degrees from the 53. So in other words, 180 plus 53.13. That is 233.13. What I can say is negative 5, 233.13. What that means is go 233.13 degrees and go wherever that angle is, you're going to go in the opposite direction 5. Okay? So instead of going 5 this way, I'm going to go 5 this way. That's what the negative means. It means go to this angle, and then instead of going 5 on that angle, you go in the opposite direction and go 5. Okay? So if you do see a negative, that's what that means in polar coordinates. Okay? Now, here's a polar graph. Isn't this cool? All right, listen, guys. Oh, gosh, this is hard to, I don't like the way this is exactly, but at least it's hard for my old eyes to see. I'm going to just draw. There's X. Or here's the vertical and horizontal, just so I can keep straight. Okay, and I think this is going by 15 degrees. This is 15, 30, 45, 60, 75, 90. Okay, this is one. Okay, well, we're going to go, let's go by twos so that I can have room, okay? But we just want to be consistent. They mark off 2, and look how they do it. This is a radius of 2, radius of 4, radius of 6, let's say, okay? 2, 4, 6. All right? So if I want to graph the point 5, 53.13 degrees, then I will first go 53.13 degrees. Let's see, 45, somewhere around here. Okay, there's my angle, but I'm only supposed to go a distance of 5 on that angle. So there's 2, 4, halfway would be here. Do you see it? That's why they use the radius to help us find. It's a great way to graph, okay, because we want this distance to be 5. So I went, here's a radius of 2, radius of 4, halfway between would be 5. Now notice the rectangular coordinates of this. Whoops, sorry. I'm going cockeyed. The rectangular coordinates of this are still, if I go perpendicular here, it's still 3, 4. All right, this point is 3, 4 in the rectangular way, telling me to go 3 horizontally, 4 vertically, or I go a distance of 5 at a 53.13 degree angle. They're both going to be the same spot, whether I have a polar graph. This is the way a polar graph looks, not the rectangular system. The rectangular system's a little bit hard to judge the angles. So this is a polar graph. I gave you both. I'd like you to try to plot both on there. You can pause me if you want. Okay? All right. Let's find the rectangular coordinates of this polar coordinate points. Okay, this is 6, this is r, and this is theta. Okay? That's r and that's theta. So we have to remember that x equals r cosine theta, y equals r sine theta. All right? So x equals 6 cosine of 2 pi over 3. I know r and theta. Y equals 6 sine of 2 pi over 3. We'll finish that at the next video.